Good morning, students. So in our last class from the chapter integration, we discussed the first method, which one is substitution method, isn't it? So through this method, we solved some questions also. So now today actually what you have to do with the help of this method, substitution method, now we have to do some questions from the exercise 7.2. So now here, if you see the first question, so all questions are not possible here, so that's why we have to do some few questions here. So that's why if you see this question, the question is given like in this way, x cube minus 1 to the power 1/3 into x to the power 5. The question is given this one. So now here what you have to do, we have to integrate this one. So that's why first of all, this question, how can we solve? You see first. So first of all, we have to take, let I equals to integration x cube minus 1 to the power 1/3 x to the power 5 dx. Actually this one is the question, isn't it? So this one is the question we have to solve. With the help of integration we have to solve this one. So now if you see here x cube minus 1, so this one is given here x cube minus 1. If we check out the question one more time, x cube minus 1 1/3 x to the power 5 dx. Okay, now here x cube minus 1, here it is given x to the power 5, so the power is given here 1/3. So what you have to do, how can we rearrange this result? You see here x cube minus 1 is there, so that's why if we write the result like in this way, if you see here x cube minus 1 to the power 1/3 and here x to the power 5. So if we write this x to the power 5 into two parts, this one if we write x cube into x square dx, meaning is same, isn't it? This one is the main step here. What you have to do, we have to break this result x to the power 5. X to the power 5, if we break x cube into x square, easily we can write, if you calculate this, again we get x to the power 5. So now after that, the integration, the substitution method is very comfortably we have to do here. What you have to do, just we have to substitute this x cube minus 1, because ddx of x cube is what? 3x square. 3 is the constant term, so if you take 3 outside, then here x square remains, so x square is present here. So that's why what you have to do, we have to substitute this x cube minus 1. So that's why if you write here, let z equals to, this one we write here x cube minus 1. So if z equal to x cube minus 1, we write so that's why we have to write this one is so that, define setting this one with respect to x. So that's why we have to write this one is dz by dx equals to, later on we have to directly write dx on right hand side. Now here dz by dx, ddx of x cube is what? We have to write this one is 3x square and ddx of constant term 0. So that's what you have to write, 3x square. So now if you cross multiply this 3 and dx, then we get this result dz by 3. dz by 3 equals to, this one we get here x square dx. Is it clear? So now if you see this part x square dx is present here, if you see, isn't it? So that means in place of this x square dx, what we can write? We can write dz by 3. So in place of this x square dx, we can write dz by 3. Is it clear? And at the same time, you see here x cube minus 1, we consider z equal to x cube minus 1. If you see here, this one is x equal to z, x cube minus 1 equal to z. So that means in place of x cube minus 1, easily we can write z. Now here this x cube, what you have to do, so in place of x cube, now if you see here, if we keep this x cube here 1, if we shift to left hand side, then from here what we can say, x cube equal to how much? X cube equals to, we can write here z plus 1. X cube equals to, we can write z plus 1. Can we write? Easily we can write x cube equal to z plus 1. So that means in place of this x cube, we have to write z plus 1. And now here in place of x cube minus 1, we write z. And in place of x square dx, we can write dz by 3. Is it clear? If we substitute these 3 results, so easily we can solve this question. All of you understood this one? Now let's see how can we solve this. So from here, what you have to do? Now, if we write now I equals to, therefore we write here I equals to integration. If you see the solution there, x cube minus 1, in place of x cube minus 1, we write z. So that's why we have to write this one is z to the power 1 by 3 into, then remain there x cube. In place of x cube, what we write? We write z plus of 1. Is it clear? and finally the last one is x square dx. So in place of x square dx, what we write? Dz by 3. So that's why we have to write this one is dz by 3. Is it clear? So this one is our substitution. So after substitution, so easily we can solve this one now. Is not it? What you have to do? What you have to do? So you see here 1 by 3 constant term, and this z to the power 1 by 3 we multiply with z, as well as we have to multiply with 1, and easily we can separate the result. So that's why 1 by 3 is the constant term, so we have to write this one outside. So integration z to the power 1 by 3 into z. How much we get here? 3 plus 1 here, 4. So that means this one we have to write z to the power 4 by 3 plus of this one we have to write z to the power 1 by 3, z to the power 1 by 3 into this one we get simply dz. Z to the power 1 by 3 plus 1. If the base is same, we add the powers. So 1 by 3 plus 1. 1 by 3 plus 1 is how much? 4 by 3. So that's why we write this one is 4 by 3. So ultimately, if we separate the result here, 1 by 3 constant term, so integration, so first one we have to write z to the power 4 by 3 dz plus of, second one we have to write z to the power 1 by 3 dz. Is it clear? So this one we write. Now I think all of you understood which formula we have to apply here. d dx of x to the power n dx. So x to the power n dx means x to the power n plus 1 divided by n plus 1. So if we apply this formula here, so we get 1 by 3 constant term. Then here in place of this one we have to write z to the power 4 by 3 plus 1. 4 by 3 plus 1 means how much? 7 by 3. So that's why we have to write this one is z to the power 7 by 3 divided by this one we have to write 7 by 3 plus of this one what you have to write 1 by 3 plus 1, that means 4 by 3. This one we have to write 4 by 3 divided by 4 by 3 plus of c, where c is an integrating constant. Is it clear? So after that all of you know what you have to do. In place of z we have to substitute the result again. Z means what? X cube minus 1. So in place of z we have to write x cube minus 1 again, and then we get our required answer. Is it clear? So you have to complete this solution here. In place of z what you have to write? X cube minus 1. Okay, now the next question is, if you see the question is given here, integration, what you have to do? The question is given 1 by x log x to the power m, where x greater than 0 and m is not equal with 1. So this one is the question here given. So if you solve this question, what you have to do? First of all, if you write here, let I equals to integration, this one you have to write 1 by x into log of x to the power m, log of x to the power m dx. So this one is the question, isn't it? Integration 1 by x log x to the power m dx. So now in this case what you have to do? Let's see here first of all. So now here if we substitute x, d dx of x is 1. So what we have to do here in place of log x? But if you substitute this log x, d dx of log x is what? 1 by x. So 1 by x is present here. So in this way, when we have to apply the substitution method, first of all we have to identify the substitution part. If we substitute any variable or any function here, the differentiation part is present there or not. If present, then we can substitute, otherwise it is not possible. Is it clear? So in this case what you have to do, you have to substitute this log x. So if we arrange the result one time, so what you have to write here, integration, this one we can write 1 by log x to the power m. So 1 by log x to the power m we can write, and 1 by x dx if we write separately, we just arrange the result here, 1 by x dx. Is it clear? So this one we write. Okay, now here what you have to do, now here we have to substitute this log x. So that's why let z equals to log x. So if you substitute this z equal to log x, then what we get? Let's see. So we have to differentiate this one with respect to x. So that's why we have to write here, so that dz. If you differentiate this one with respect to x, dz by dx equal to d dx of log x is what? 1 by x. So that's why we have to write this one is 1 by x. Is it clear? So now if you cross multiply this dx here, now what you have to write? This one you have to write dz equals to, this one we have to write 1 by x dx. Now you see here, this 1 by x dx is here. So in place of this 1 by x dx, what we can write? We can write dz. So that means in place of this 1 by x dx, easily we can write dz. And in place of log x, what we can write? We can write z. And m is what here? Any integer here. So what you have to do now here? We have to substitute these two results. So therefore, if you write here I equals to what you have to write? Integration 1 by z to the power m. In place of log x, you see, in place of log x, what we write? Z. Log x means z, so that's why we write z here, z to the power m. And 1 by x dx means what? 1 by x dx means we can write dz. So that's why we have to write this one is dz. Is it clear? So now here what you have to do, easily we can apply the formula x to the power n dx. How can we apply this one? So this one also we can write z to the power minus of m dz. 1 by z to the power m. In plus it we get this type of result. So if we apply the formula here, then we have to write here z to the power minus of m plus of 1 minus of m plus of 1 plus of c, where c is an integrating constant. So z means what we consider? Z means log x. So in place of z, we have to write now here log x. So that's how we have to write log x to the power minus m plus 1. That means we can write this one is 1 minus m. And here also we can write 1 minus m plus of c, where c is an integrating constant. So this one is our required answer. I think all of you understood this one. Is it clear? Okay. Now the next question is, if you see the question is here, question is given e to the power tan inverse of x divided by 1 plus x square, and this one is question number 18. So very simple question this one. So how can we solve this question? Let's see here. So what you have to do, let I equals to integration. The question is given here e to the power tan inverse of x. So e to the power tan inverse of x 1 plus x square. So 1 plus x square into dx. This one is the question given, isn't it? So e to the power tan inverse of x divided by 1 plus x square. So now in this case what you have to do, you see here tan inverse of x is there. So very simple question this one, because ddx of tan inverse 6 here, what, 1 by 1 plus x square, isn't it? So that's why easily we can substitute this tan inverse of x. So that's why what you have to do, if we arrange this result, so if we write this one e to the power tan inverse of x into, if we separately write 1 by 1 plus of x square, 1 by 1 plus of x square dx, we just rearrange the result 1 by 1 plus x square separately we write here. Is it clear? If you understood, then no need to write, you can directly write the result. So now here what you have to do, we have to substitute this tan inverse of x. So that's why what you have to write, let z equals to tan inverse of x. So tan inverse of x, any variable you can substitute. Here I write z, you can write t, m, any variable you can substitute here. So that if you differentiate this one, differentiating this one with respect to x, so that's how we have to write this one is dz by dx. So dz by dx equal to what you have to write, ddx of tan inverse of x is what? 1 by 1 plus x square. So that's why we have to write this one is 1 by 1 plus x square. Is it clear? So now here if you cross multiply this dx here, so that's why we have to write dz equals to we have to write 1 by 1 plus x square into dx. Now you see here. So here 1 by 1 plus x square dx is there. So in place of 1 by 1 plus x square dx, here this one is present. So in place of 1 by 1 plus x square dx, what we can write? We can write dz, and tan inverse of x means what we substitute? Z. So we can write e to the power z. Isn't it? Very simple question. So that's what you have to do. Therefore I equals to integration. This one we have to write e to the power z into dz. Isn't it? 1 by 1 plus x square dx. That means in place of this one we can write dz, and tan inverse of x means z. So we write z, e to the power z dz. Is it clear? Okay. Now here, if you integrate this one, since it is of the form integration e to the power x dx, what is the result of e to the power x dx? E to the power x. So that's why we have to write here e to the power z plus of c. Is it clear? So if we write this one, z means what? Z means you see tan inverse of x. So that's why we have to write this one e to the power tan inverse of x plus of c, where c is an integrating constant. So this one is our required answer. I think all of you understood this one now, isn't it? Okay. after question number 18, if you see the next question is very important question here. So if you see the next question is given here. If we directly write here, let I equals to this one, you have to write integration of the numerator part here given e to the power twice x minus 1, and in denominator this one is given twice x plus of 1, so into dx. So this one is the question here, e to the power twice x minus 1 divided by e to the power twice x plus 1 dx given. So this question is very important examination point of view. So this one is the question number 19. So now how can we solve this one? So to apply the substitution method here, first of all what you have to do, we have to rearrange this result. Is it clear? Very important. We have to rearrange this result, and let's see how can we rearrange. You have to know this one, you have to know this technique to rearrange this result. So first of all what you have to do, e to the power twice x is there, isn't it? So you can directly taking common e to the power twice x, or we can take in this also, you see here e to the power twice x. So e to the power twice x means also we can write this one is e to the power x whole square. Can we write minus of 1, isn't it? And here we can write here e to the power x whole square plus of 1 into dx. Can we write like in this way? Yes, easily we can write here, because in class 8 we get this type of indices a to the power mn. In place of a to the power mn, this one we can write a to the power m holding to power n, or also we can write a to the power n holding to power m. This type of results we write or not. So from here easily we can write this result, e to the power twice x, that means e to the power x whole square we write, e to the power x whole square we write. Is it clear? First step you have to know this one. Is it clear? Okay, now next one is, so from this indices actually we write this result. So now after that what you have to do, next very important step is what? You have to take e to the power x common from the numerator, as well as e to the power x you have to take common from the denominator also. So if you take e to the power x common from numerator, so that's why e to the power x common. So if we take e to the power x common here, what will remain here? E to the power x whole square. So 1 e to the power x we take common, so that's why here remain e to the power x. Is it clear? But in this second part you see only 1 is there. So what you have to write? E to the power x already we take common, so that's why we have to write minus 1 by e to the power x. To balance this result we have to write like in this one. Is it clear? I think all of you understood this one. Now again if you multiply this one, you see e to the power x, e to the power x, e to the power x whole square, and if we multiply it with this e to the power x, e to the power x cancel, so here remain 1. Is it clear? The meaning is same here. Similarly, if you take e to the power x common in the denominator, so what will remain here? Here remain e to the power x minus of this one. To balance this result we have to write e to the power x, this one is plus, into dx. I think all of you understood this one. To balance this result we have to take e to the power x, e to the power x common, and then we get this 1 by e to the power x, 1 by e to the power x. Is it clear? So now in this case you see this e to the power x, e to the power x cancel, isn't it? So that's why what we get here, or this implies I equals to integration in the numerator part here remain e to the power x minus e to the power minus of x. 1 by e to the power x means what we can write? E to the power minus x we can write, and similarly here this one is e to the power x plus of e to the power minus x into dx. Is it clear? So this one we write 1 by e to the power x means e to the power minus x. So if you substitute this denominator part here, you see ddx of e to the power x is what? E to the power x, and ddx of e to the power minus x is what? Minus e to the power minus x. So that's why both the results are present here. So that's why we have to substitute this denominator part. So that's why what you have to write, let z equals to we have to write e to the power x plus of e to the power minus x. So we have to substitute this result, so that what you have to write, so that dz, define setting this one with respect to x, so dz by dx equal to ddx of e to the power x, we have to write this one is e to the power x, and ddx of e to the power minus x we have to write here minus e to the power minus x. Is it clear? So now if you cross multiply this dx, so that's why we get here dz equals to this one is e to the power x minus e to the power minus x into this one we write dx. I think all of you understood this one now. So these steps are we have to do. That's why this question is very important. And now after substitution we get this result. So now you see here e to the power x minus e to the power minus x dx. E to the power x minus e to the power minus x dx. So if you see this numerator part is this one, e to the power x minus e to the power minus x dx. So in place of this numerator part here, this numerator part, in place of this numerator part, what we can write? Dz, and this denominator part equal to what? Z. So therefore I equals to what we write? I equals to integration. In numerator part we have to write z, and in denominator we write numerator part dz and denominator z. You see, e to the power x minus e to the power minus x dx. This one is the numerator part. Numerator part is e to the power x minus e to the power minus x dx. That means in place of numerator we write dz, and in place of denominator we write z. So I think all of you know the formula of this result. What is the result? So this one you have to write log of z plus of c. Dx integration dz by z, 1 by z dz. That means it is what? Log z. So that's why we write log z plus c. So z means what? Z means we consider e to the power x plus e to the power minus x. So that's why in place of z we have to put this result. E to the power x plus e to the power minus x we have to put here. Is it clear? Then we complete our solution here. We get the solution this one, and which one is our required answer. I think all of you understood this one now here. So in this way actually is the substitution method we have to do. So in our next class some more questions from the exercise 7.2 we have to do, and the remaining questions you have to do by yourself, and let's check out how many questions you can solve. Is it clear? I hope all of you understood this three questions. So in our next class we have to continue this. Is it clear? Okay, thank you.